Dear students, today we will discuss some more theorems on continuity. If a function f(x) is continuous in closed interval ab and cb any point belongs to open interval ab such that f of c is not equal to 0, then there exists a real number delta greater than 0 such that fx has the same sign as f of c. So before proving this theorem, we should know about the continuity of the function in closed interval ab. It means function is continuous in open interval ab and right continuous at a and left continuous at b. So fx is continuous in closed interval ab. It means it is continuous at C. C be any point of the interval AB, open interval AB. So using definition of continuity, for every epsilon positive, there exists delta greater than 0, such that absolute difference of fx and f of c is less than epsilon whenever x माइनस सी का एब्सोल्यूट डिफरेंस डेल्टा से छोटा होगा. It is the first statement. Since given that value of the function at c is not equal to 0, so by trichotomy rule, f of c will be greater than 0 or less than 0. So in first case, let f of c is greater than 0. Then we have to show that f of x will be greater than 0 in the interval. So for every epsilon positive, there exists delta greater than 0 such that f of x minus f of c absolute difference will be less than epsilon whenever absolute difference of x and a less than delta. Since epsilon is arbitrary real number, it will depend on choice of us. So no loss of generality. Epsilon will be taken as half of f of c. This epsilon should be positive. So, but where f of c is also positive, so no problem. Taken epsilon in this way. Since epsilon is positive, then half of f of c greater than 0. So using condition of continuity, replace epsilon by half of fc. So we are getting this result. So absolute difference of f of x and f of c less than half of fc, expanding, or breaking the absolute sign. Then we can write f of c minus half of f of c less than f of x less than f of c plus half of f of c. Implies that half of f of c less than f of x less than 3 by 2 f of c. Obviously, f of x will be greater than half of f of c and f of c is positive, so greater than 0. So, f of c greater than 0, then there exists open interval c minus delta c plus delta. X will be chosen from here. So you can say कि f of c and f of x has a same sign. Now we consider second case. Let f of c is less than 0. So in condition of continuity, we choose especially epsilon equal to minus half of f of c. Since f of c is negative, so minus half f of c will be greater than 0. So using this in the condition of continuity, absolute difference of f of x and f of c less than epsilon whenever absolute difference of x and c less than delta, replacing epsilon by minus half of f of c. Whenever x belongs to open interval c minus delta, c plus delta, we break the absolute sign. F of c plus half of f of c less than f of x less than f of c minus half of f of c. For all x belong to open interval c minus delta and c plus delta. Solving 3 by 2 f of c less than f of x less than half of fc. For all x belongs to c minus delta, c plus delta upper interval. Now we check here. F of xc is less than 0 for all x belongs to c minus delta, c plus delta. So this is the end of the theorem. So it is a complete proof of theorem. Before proving this theorem, we have to understand every word of the theorem, which will be helpful to write the proof of the theorem. Thank you.